How are you? I hope you are coping very well with the situation, the COVID era, the lockdown, reading at home, doing work at home, and then studying at home in Mudirodio. Thank you for being there. Thank you for watching. Thank you for the resilience. Keep on, hang in there. It shall all end. This COVID-19 shall end and you'll come back to school. Just take this very seriously. Each day of your life, take it seriously. These little things that you're having, be attentive. Never know. You might get something out of what we are talking about. So I welcome you once again, and we are going to pick up from exactly where we stopped last week. Before that, I want to sympathize with all of you who have got challenges during this time, from the time when we last met until today. Sorry, may God strengthen you. And all those who have got things to celebrate, your birthday and all good things that have happened in your life, we praise God for that. And we continue praying for you for more years, especially those who have celebrated birthdays. Okay? We go. Last week, we moved our journey into studying different concepts of the mole. Remember, you introduced yourselves to the mole concept in the previous weeks. You talked about, you defined the mole, you defined relative formula mass, relative molecular mass, you calculated them, the Avogadro's number, and all that. Then last week we looked at calculating moles from mass. That is when we are given mass. And then we also looked at calculating mass when we are given moles. That's what we looked at in our last week, and you had some little work to do. I hope you tried it out. I hope things moved on very well for you. Today, we are continuing to look at another concept of the mole. What concept is that? Percentage composition. That's what we are beginning with today. And just like our topic suggests, we are going to be doing calculations. So I really hope you have somewhere to write, your book ready, your pen ready, and your calculator, so that we can work out these calculations together. Okay? So let us go. Our subtopic is percentage composition. Why are we studying about percentage composition? We want to compare, we want to know the amount of given elements in given compounds. Percentage compositions also help us to determine the formulae of given compounds, okay? Yeah, so we need to know percentage, that is percentage composition, and here we are mostly going to look at percentage by mass. Percentage by mass. If I have my compound sodium chloride, can I know the amount of sodium only in sodium chloride? Can I know the percentage by mass of sodium alone in sodium chloride? Can I work out the percentage of chlorine only in sodium chloride? Or if I have any other compound, sodium nitrate or calcium carbonate, lime, what is the active part of this substance? Why do I have to have this amount, this big amount, or this small amount to perform this small duty? If you have a compound and you want to make or to get a use of that compound, then you should know what that compound is made up of. okay? You should know if the use that I want, or if I want to use a substance, for example, as a fertilizer, if I want to get which one is the best fertilizer, I should know what component makes a substance a good fertilizer. Which component is that? Nitrogen, very good, nitrogen. So it means I would go ahead and calculate the percentage of nitrogen in the different fertilizers that I have. Then I'll know, oh, the one that has the higher percentage of nitrogen should be the better fertilizer. So that is why we are looking at this. We may want to know how much water is in this compound, especially if the substance is hydrated. How much of the water is there? Why do I want even to know the hydration or whatsoever? There are very many reasons, because I know most of you are going to become inventors. You're going to do drugs for us. You're going to come up with so many things. You're going to invent medicines and all that. So if you're going to do all those inventions, then you should know that substances or elements that make up a compound are there in different portions, okay? So we are basically going to be calculating the portion of a given element in a given compound, or the portion of a given substance in a big compound, okay? So we are going to go, how do we calculate the percentage by mass? If I'm going to calculate the percentage by mass of a given element or substance in a given compound, then I should know percentage. I'm going to do this. Percentage by mass is given by, if it is an element, then I'll look at the atomic mass of the element divided by the relative formula mass of the element, and then, sorry, of the compound, not element, okay? The relative formula mass of the whole compound, and then I'll multiply this by 100%, okay? If I'm looking at percentage by mass or percentage composition by mass of an element in a compound, for example, supposing I have my compound as sodium chloride. And I want to calculate the percentage of sodium in sodium chloride. Calculate the percentage of sodium in just that. Remember, here I have not specified in a given mass of sodium chloride. I've just said in sodium chloride, just like that. It means I am looking at only 1 mole of sodium chloride, okay? If I've not talked about in 2 grams of sodium chloride, or calculate the mass of sodium in 5 grams of sodium chloride, then it means I'm just going to be looking at 1 mole, okay? So if I'm going to get the mass of 1 mole of sodium chloride, to remind you, the mass of 1 mole of sodium chloride is the what? It is the relative formula mass, okay? So I'll get the Rfm of sodium chloride, whereby we said that if I'm going to get the Rfm of a substance, I should know the correct formulae, or in this case, the correct formula of the substance, okay? So the formula for sodium chloride Do my friends know it? Okay, so let me just write it. It's right there. Sodium chloride. So we determine the Rfm of sodium chloride, and I hope you remember, but let me remind you, if I'm getting the Rfm of sodium chloride, I would add the relative atomic mass of sodium plus the relative atomic mass of chlorine. The relative atomic mass of sodium is 23. So this will be 23 plus the relative atomic mass of chlorine, which is 35.5. And when I add these two, I will get 58.5. Remember, we said relative formula mass is a ratio. It is a ratio. So being a ratio, we do not put their units. So this is the relative formula mass, the mass of 1 mole. Now, if I'm calculating the percentage of sodium in sodium chloride, I would go ahead and I use my formula. That one. So I will look out for what is the mass or the relative atomic mass of sodium. The relative atomic mass of sodium we are saying is 23, okay? So I would simply come here and say percentage of sodium, I can use the formula, is equal to the atomic mass of sodium, which is 23, out of the Rfm, the total mass, the mass of 1 mole, which is 58.5, and I will multiply that by 100%, like that. So I will go ahead and get my percentage. Those of you who have calculated, what percentage have you got? We are using our calculators. So on my calculator, I would put 23 out of 58.5 times 100%. Okay? So you should have something close to that. 0.39, actually 0.32, 0.32%, okay? When you are getting your answers, you need not round off so much. Like you don't have to round off to the whole numbers, okay? You can round off to 2 decimal places. But remember, even more decimal places would give you a more accurate answer. Even 4 decimal places would be okay. So that is our first example, okay? We have calculated the percentage composition of sodium in sodium chloride. And that is what we have got. We are saying if my compound is sodium chloride and I want to get the percentage composition of sodium in sodium chloride, I should first of all get the Rfm of sodium chloride, which is the mass of 1 mole, and that we have calculated here. Okay? We have got it. We don't put their units because we said Rfm is a ratio. Okay? Then we go ahead to get the percentage of sodium like that. The atomic mass of sodium out of the relative formula mass of the whole compound times 100%. Okay? So this should be like that. So the answer that we are getting is the percentage. When I get this, I know that I have some mathematicians watching like that. So this, when I work it out, it should give me that as a percentage, okay? So we go to the second example. Example 2, it is calculate okay, calculate the percentage composition of each of the elements in ammonium sulfate, okay? Calculate the percentage composition of each of the elements in ammonium sulfate. How do we do this? We are saying if I'm going to get the percentage composition, in this case of each of the elements in this compound, first I should know the relative formula mass of the compound, because the relative formula mass of the compound is the mass of 1 mole of this compound, okay? If I'm going to calculate the RFM of the compound, I should know the formula of this compound. Do we know the formula for ammonium sulfate? I know some of us have already learnt this, how to write formulae. So in ammonium sulfate, you have 2 radicals. You have the ammonium and the sulfate. I want to derive it for us. Ammonium, we have the ammonium radical with a valence of 1. Then you have the sulfate with a valency of 2. So when we are writing the formula, this 1 comes down there, this 2 comes here, and this 1, we take it here, so that now our formula will become ammonium like that. We put it in brackets because when we are bringing these 2, it is going to this whole species, okay? So that will be with a 2, and you have ammonium sulfate like that, okay? So this is our formula for ammonium sulfate, which we use to calculate the RFM. So what we are going to do is to get RFM of ammonium sulfate now. So this is going to be equal to, we start with our nitrogen. How many nitrogens are we going to have in this compound? Because we have a 2 here, we are going to multiply this by 2. Let me repeat that. When we are getting the RFM, we are getting the total mass of the elements in the given compound, we put into account the number of atoms, okay? We put into account the number of atoms present. So if the compound has, for example, nitrogens are more than 1, then we would multiply the number of atoms of nitrogen times the relative atomic mass of nitrogen. This we studied already. But it is okay to repeat a bit. So here, because we have a 2 here, it means we have 2 nitrogen atoms. So this is going to be nitrogen, the atomic mass is 14, we multiply by 2, and we add, the atomic mass of hydrogen is 1. How many atoms of hydrogen do we have? We have 4 times 2. Because there is a bracket, we would multiply, we wouldn't just add. So this is 1 times 4 times 2, okay? Plus the atomic mass of sulfur is 32, and we have only 1 atom of sulfur, so we don't have to multiply by 1. Then oxygen is 16, and how many atoms of oxygen do we have? They are 4. So we multiply that by 4, and we shall get 14 times 2, that's 28. 1 times 4 times 2, that's 8, plus 32. 16 times 4, that is 64, and then we add up everything, and we shall have 132 as our RFM for ammonium sulfate. Now, they have asked us to calculate the percentage composition of each element. So it means I should identify the elements in ammonium sulfate, which are nitrogen, hydrogen, sulfur, and oxygen, okay? So I would simply have percentage let me begin with nitrogen. Percentage of nitrogen, we are saying if I'm getting percentage of nitrogen, I should get the relative or the mass of nitrogen. Should be mass of nitrogen out of the relative formula mass times 100, and this will be my percentage, okay? So I will get, what is the mass of nitrogen? In this case, I'm not only using the relative atomic mass. Why? Because the nitrogen atoms are more than 1 in ammonium sulfate, okay? Because of this bracket here and these 2 here, it means there are 2 nitrogen atoms. Therefore, if I'm going to get the mass of nitrogen, I will get 2 and I multiply by 14, okay, the relative atomic mass. Then I have out of the RFM, which is 132, and then I multiply this by 100, and this will give me my percentage. So in this case, it is the same mass here that we used when we are calculating the RFM. I would even just extract it from here. So that gives us 28 out of 132 times 100%. And what do we get? Those of you who are having the calculators near, you have something like that. So I would do that, then I would go ahead to get percentage of another element. So in this case, I can say percentage of, I could look at hydrogen. So I have hydrogen. Again, it would be percentage of hydrogen should be given by the mass of hydrogen out of the relative formula mass times 100, and this is my percentage. Okay? So this is simply going to be, I go again, I look at my formula. Okay? There you have how many atoms of hydrogen. That is very important because the number of atoms of hydrogen should help us to determine the mass of hydrogen. So we know the relative atomic mass of hydrogen is 1, and we multiply it by the number of atoms of hydrogen present. In this case, they are, we saw it down there when we were calculating the relative formula mass. So it had 1 times 4, then times 2 out of the RFM, which is 132, and we multiply this by 100, and we have our percentage. So this is 1 times 4 times 2, which is 8. Okay? 8 out of 132 times 100%, and we get our answer. So you would use your calculator to put 8 out of 132 times 100, and your answer should be around 6.06%. Okay? So a good student would go ahead and tell me, therefore you would conclude, therefore, the percentage of hydrogen in ammonium, or the percentage composition by mass of hydrogen in ammonium sulfate is 6.06%. Okay? So you would do this also for sulfur, and you would do the same for oxygen. I hope we are following. So I'm going to rub this, then I do that of sulfur, and then that of oxygen. So just a moment as you take note, a few seconds. So you're saying percentage of hydrogen would be mass of hydrogen out of the relative formula mass times 100%. Okay? And we get our answer. Okay? So that is it. Okay, so I guess those who are writing, we can continue. We can continue to look at the percentage of sulfur. And the percentage of oxygen. Actually, what I'm going to do, I'm going to look at the percentage of sulfur. Then you will calculate in your free time the percentage of oxygen. So this was 60. So the percentage of sulfur, again, we are saying it is mass of sulfur in ammonium sulfate out of the RFM times 100%. So in this case, we are going to have the mass of sulfur. We go back to our formula of the compound. We have just 1 atom of sulfur, okay? So we have nothing to multiply with. Our relative atomic mass of sulfur is 32. So this would simply be 32 out of our RFM, which is 132, times 100%, and I would get my answer 32 out of 132. What do you get? You should be trying out using your calculator. So I should have around 24.24%. Should I go through that same long procedure to get the percentage of oxygen? Someone should tell me. Yeah, I know you are talking there at home. Do I have to go through this? Is there any other way I would get the percentage of oxygen? Because I have already got the percentage of nitrogen. I have also calculated the percentage of hydrogen. I have also calculated the percentage of sulfur. In which other way, apart from using this formula, can I get the percentage of oxygen? I'm leaving for you that as homework. There is another way. Try it. Can you scratch your mind? Do I have to go through this and I say mass of oxygen out of the Rfm times 100, or I can do it in any other simpler way? Yes, you can. Yes, you can. 1 minute, actually a few seconds to look at that, and we'll look at our last example under this. You should be taking notes very fast. I know you've already written this. Okay, our last example is simply going to be number 3. Calculate the percentage of water of crystallization in sodium carbonate 10 water, like that. Okay? What are we going to do? So do you see we are moving from hard to harder to harder, okay? So here we have calculate the percentage of water of crystallization. This is what I told you, that sometimes they will ask you to calculate the percentage composition by mass of just one element, and another time it will be calculating percentage composition of maybe a molecule in a given compound, like this one. So you have sodium carbonate 10 water. We should know the relative atomic masses. Sodium is 23, carbon is 12, oxygen is 16, and hydrogen is 1. So we are saying if I'm going to get the percentage composition by mass of water of crystallization, of water of crystallization in sodium carbonate 10 water, I should first of all know the Rfm of sodium carbonate 10 water. If I'm to know the Rfm of sodium carbonate 10 water, I should know the correct formula of sodium carbonate 10 water. I will not take a lot of time on that. I know you've done this already. I even tried deriving for you for the previous example. So that is our formula for sodium carbonate 10 water. Okay? So we are going to get the Rfm. Rfm of our sodium carbonate, 10 water. It is going to be given by, we have sodium, the atomic mass of sodium is 23. How many atoms of sodium do we have? 2. So we'll multiply that by 2. Plus carbon, the relative atomic mass of carbon is 12. Okay, and we have just one carbon atom. Then here we have oxygen. Oxygen, how many atoms of oxygen do we have here? There are 3. So this is 16 times 3, plus we have some water, and we have 10 moles of water of crystallization. So this is going to be plus 10, and we put a square bracket. Why? Because inside there are also other things to add. When you look at water, this 10 is multiplying through this whole water, okay? So we are going to have 10, we put square brackets, into hydrogen. What is atomic mass of hydrogen? It is 1. How many atoms of hydrogen do I have here? They are 2. Plus, what is the relative atomic mass of oxygen? That is 16. So I'll close my bracket from there, like that. So this is simply going to be 23 times 2, 46, plus 12, plus 48, plus 10 times. So what is 1 times 2? That would give us a 2, plus 16, that would give us 18. So this is 10 times 18, which is 180. And when we add up this, we get 286, like that. So if I'm getting the percentage of water of crystallization, therefore, what will I do? What will I do? I should know. So if I'm getting now percentage of water of crystallization, it is going to be equal to the mass of this water of crystallization that I'm talking about. I divide this with the relative formula mass, and I multiply this by 100, and my answer that I will get will be a percentage. Okay? So this is going to be equal to the mass of water. How do I know the mass of water? I will come back here in my formula, and by the way, when you are calculating here the RFM, you get an insight of how you will actually know the mass of the substances. So when I am looking out for water, this is our water. Okay? Remember, I have here this dot showing me that I have sodium carbonate and then I have water. This is how we represent hydrated compounds. This number 10 here is telling me that I have 10 moles of water here present. Okay? So when I'm getting the mass of water, I will get the 10, okay? 10, just like the way we did it here, and I multiply it by the mass of hydrogen and that of oxygen after summing them, just like we did here, okay? So this is going to be equal to 10 times, or let me just use brackets, 10 into 1 times 2 plus 16 out of 286 times 100%. And this is going to be 10 times 18. So you have 10 times 18 out of 286 times 100%, and you would get your answer. 10 times 18 is around 180. Actually, it's not around, it's exactly. 10 times 18 is 180. Out of 286, you do that on your calculator, times 100%. What do we get? So our answer is 62.94%. So that is percentage of water of crystallization. You would go ahead, actually, you would go ahead and conclude, therefore, the mass, the percentage composition by mass of water of crystallization in sodium carbonate 10 water is this. Now, lastly, today, as I want to give you an exercise, and it's going to be flashed on your screen. I want you to write it. You're going to take 2 minutes to write it. Then we do our wrap up of the lesson. But let me read it for you as you write. Number 1 says, determine which oxides of iron, that is iron 3 oxide or tri-iron tetraoxide has more iron. Determine which oxides of iron, which of the oxides of iron, those ones, iron 3 oxide and tri-iron tetraoxide has more iron. What are you going to do? Simple. Calculate the percentage of iron in iron 3 oxide. Calculate the percentage of iron in tri-iron tetraoxide. Then you have number 2, which of ammonium nitrate and ammonium sulfate is a better fertilizer. If they're asking you which of those two is a better fertilizer, what do you think shall be required of you? What do we know about fertilizers? What do fertilizers have? What is, especially when you look at ammonium nitrate and ammonium sulfate specifically, because I know there are other fertilizers that have other components. With these ones, these ammonium salts that we are looking at, what makes them good fertilizers is the presence of nitrogen. So that is just a hint. Then you have the last one, calculate the mass of water in 12.5 grams of hydrated copper 2 sulfate. And in this case, I've given you the formula for the hydrated copper 2 sulfate. It means in number 1, I've given you the formula. It will be easy for you to calculate the Rfm. In number 3, I've also given you the formula. It will be easy for you to calculate the Rfm. In number 2, you will have a bit of job to do. You will have to first of all calculate, not calculate but write the correct formula for ammonium nitrate. Then you have to also write the correct formula for ammonium sulfate, the correct formula for ammonium nitrate and the correct formula for ammonium sulfate. Then you use them, calculate the Rfm. After getting the Rfm, calculate the percentages of nitrogen. That is number 2. Number 3, also you have some bit of work to do. You are going to compare moles, okay? Remember we calculated moles in our last lesson. If Rfm is mass of 1 mole, can I use that to also get the percentage of water in only 12.5 grams? So that is something for you to think about, and that is your work that you're going to do until we meet again next time. So I want us to just a recap of what we have talked about today. In short, we have discussed how to calculate the percentage composition. It could be of an element or of a molecule in another compound or in a given compound. Okay? We have said, we have looked at a formula that if I'm going to get the percentage composition, I should know the relative formula mass of the compound. So it would simply be mass of the given compound out of the RFM times 100%. In our next lesson, we shall go ahead to look at another concept that actually uses percentages that we've calculated, which is empirical formula. That is in our next lesson. I want to thank you again for being very good students, for following, hanging there. Please keep on working hard. I'm saying hello to all my students. I know there are my students who are watching, who always tune in to watch. Keep it up, hang in there, and may God bless you till we meet again next time. Bye.
There's a new look to beauty, elegance, freedom, style. Now available in the new look of the Radiant Hair Relaxer with herbal extracts and